So our major area of concentration is going to be trigonometry, integration, and some differentiation. Now, one of the numbers that came on integration was this number. And when you look at that number, it required someone to show that when you integrate what you have this side, you end up with what you have this side. Now, always the first thing to do whenever they tell you to show, showing means that you are going to move from your left-hand side and you go towards the right-hand side. That is when it comes to showing. So whenever you are showing, you move from the left and then you go towards the right. Number two, you need to know the identities surrounding what you are going to do. Now, when you look at what we have, when you look at what you have in the denominator and what you have in the numerator, there is some kind of relation. So now you build up from that relation that sec and tan, they have a way they are related. So I'm going to use the change of variables. So I'll say that let u equals to tan of x. Now, since I've said that u is equal to tan of x, I have to go on. Since I'm going to change the variables, I have to substitute for the x. So in order for me to substitute by the x, I must differentiate. So when I differentiate u, I'll get the u is equal to, when I differentiate tan, I end up with sec squared x dx. Then from there, since I'm changing the variables, I'm going to go on and also have an adjustment in the limits, or I change the limits. So initially, I had my x limits and I have my u limits. So I'm going to come here where there is x, my lower limit was 0. I'll come here and I say u is equal to tan of x. So where there is x, I put 0. So I'll have tan of 0, and tan of 0 will give me a 0. So here I'll have my limit as 0. Then I'll come and I put pi out of 4. Then I'll also come and say u is equal to tan of pi out of 4. So when you place it in the calculator, you can use your calculator, or you can first convert pi to 1/8 out of 4. Then you get tan of 45, and tan of 45 is 1. So here my lower limit is going to be 1. Now, after doing so, you're going to go back and substitute. So I'm going to go back and I substitute, so I'll have an integral. And now my limits have changed. They are running from 0 to 1 since I've changed the variables. Then I'll have up there sec squared of x divide by 4. Since I said tan is equal to, u is equal to tan x, I'll have here minus u squared, then times my dx. Now, from this expression here, we notice very well that du is equal to sec squared x dx. So in case I want dx, it means I'll divide. So I divide this side by sec squared x, divide by sec squared x. So I end up with du out of sec squared x equaling to dx. Meaning that where there is dx, I'll put this. So I'm going to have here du out of the sec squared of x. Now at this point, when I reach this point, it means that I can go on and reduce. So you notice that this sec squared and the sec here are the same. So meaning the two can go away. So meaning that now we are going to come and we shall remain with an integral from 0 to 1. Then up I'll have du out of 4 minus u squared. Hope we are still on the same page. Now, when I reach here, I'm going to ask myself, which kind of integral, what kind of relation can I build from here? When you look at what we have in our denominator, you have to remember from your knowledge that a squared minus b squared is the same as a plus b, and then the same as a minus b. So when you look here, I can have 4 minus u squared. So in terms of a square, this becomes 2 squared minus u squared, meaning that when you expand, you'll have 2 plus u, and then you'll have 2 minus u. That means that where we have 4 minus u squared, I can write it like this. So I'll come and I say my integral from 0 to 1 is equal to du out of 2 plus u, and then I'll have 2 minus u. Now, the moment I have this, the second thing I'm going to do, I'm going to ask myself, how can I solve this? That is now where the knowledge of partial fractions is going to come in. So mean that you are going to separate them, but using your knowledge of partial fractions. So using our knowledge of partial fractions, we are going to come here and then have it solved. So I'm going to just come here and say, using partial fractions. Now, under partial fractions, we know very well when you look at our denominator, these are linear factors. So meaning that when you are dealing with linear factors, I have 1 out of 2 plus u, and then I have 2 minus u. So we say this is equivalent to a out of 2 plus u, then plus b out of 2 minus u. Now, the moment I reach this point, I'm going to just apply my knowledge of partial fractions. So I can say that this is 1 equivalent to, this is going to be a into 2 minus u, then plus b into 2 plus u. Is that step fine, everyone?
Yes.
Yes. So when we reach here, you just use any of these variables here. You can say that let 2 minus u equals to 0, or when 2 minus u is equal to 0, so it means that u is equal to 2. So you say when u is equal to 2. So when u is equal to 2, you substitute. So we shall have 1. This side we shall have a into 2 minus 2, then plus b into 2 plus 2. So here we shall have 1 equaling to b into 4, which gives us 1 equaling to 4b. And therefore, I divide by 4, divide by 4. So our b will equal to 1 out of 4. Similarly, you can go on and now let. This time round, we said 2 minus u was equal to 0. Now, this time round, we are going to do this one. So we shall say when 2 plus u is equal to 0, it means that our u will equal to negative 2. Then now you say, what happens when u is equal to negative 2? You substitute. So you say 1 will equal to a into 2 minus negative 2, then plus b into 2 plus negative 2. So this will give us 1 equaling to a into 4, then plus 0. So 1 will equal to 4a, and therefore your a will also equal to 1 out of 4. Now, after obtaining your a and b, we can go back and substitute. That means that your 1 out of 2 plus u into 2 minus u is equivalent. Your a is a quarter, so I can write it as 1 out of 4 into 2 plus u plus our b, which is still a quarter, into 2 minus u. Now, when you reach here, we go back to our integral we are dealing with. This was the integral. So here we shall say that this is the same as from 0 to 1. Then we shall have here 1 out of 4 into 2 plus u, and then plus 1 out of 4 into 2 minus u, but everything we are integrating with respect to u. So that is how you approach. Now from there, we are going to integrate. Now you remember from your knowledge of integration that when I'm integrating something, let me say I'm integrating 1 out of 2 plus u du. In the chat, can we put the answer? What do you think our answer is going to be? Just imagine you are integrating that. What is our answer? In the chat. Okay, we can start from here. Lin of u. That is techno. Very good. So that is where we start from, that when I have integral of 1 out of u du, this is the same as ln of u, then plus c. That is the meaning. So when you look at 2 plus u, this one will give us the natural log of 2 plus u. Because when you differentiate this one, you'll go back to the original answer. So I'm going to take you back now and we integrate together. So what we have
The net salary is always the gross salary minus the total deduction.
So the next one, we are going still to do the same because we have from 0 to 1. Then we shall say this is 1 out of 4. Here we have 2 plus u plus integral. Still allow me to separate them. 0 to 1. This is with respect to u. 1 out of 4. Then 1 out of 2 minus u du. If you want, you can first move this a quarter and say this is a quarter integral of 1 out of 2 plus u du. This is from 0 to 1. Then plus the integral from 0 to 1. Remove the quarter if you feel it's going to disturb you into 2 minus u du. Then now you integrate. So when I integrate here, I'll have a quarter natural log of 2 plus u plus a quarter natural log. Now here you be very careful because when you are integrating, you look at you in simple terms, what you look at what you have inside here, that this is 2 minus u. So 2 minus u, instead for it we shall have, allow me to put the negative out here, or I can just place here, we are going to have a negative. So because I want to take you back a bit, just let me just write here my side work. When I have integral of 1 minus u, what you do, you first differentiate what you have in the denominator. What you have in the denominator, when you differentiate 1 minus u, you remain with negative 1. So its integral being negative ln of 1 minus u plus c, such that when you differentiate this again, 1 minus u, when you are differentiating it, I just differentiate what is inside and then I divide. So I'll have this negative out times 1 minus u. When you differentiate it, you get negative 1 out of the original thing. So here, you notice that there is a negative here. So when I differentiate it, I'll get negative 1. So I'll put the negative out there such that it becomes a negative. So here, we are going to put our, we are going to put our negative out here, and then here we shall remain with natural log of 2 minus u. Then our limits are running from 0 to 1. Even here, they are running from 0 to 1. Even here, 0 to 1. So what are we going to do? This is going to be a quarter natural log. We can put in the 1. When I put in the 1, I'll have 2 plus 1. Then minus, I put in the 0, I'll still have a quarter ln of 2. That is the first bracket here. Then I go to the second one, but remember this is a plus and a minus. So allow me now to just write here that this is a minus 1 out of 4. I can first pull it out, no problem. Then I put in. When I put in 1, I'll get ln of 1. Then I will say minus, I put in 0, I'll remain with a quarter ln of 2. So I'm going to simplify. It becomes a quarter ln of 3 minus a quarter ln of 2 minus a quarter ln of 1 plus a quarter ln of 2. Now, what are you noticing? You are noticing that this ln here is the same as this. So those two can go away. But also you know very well that whenever you have ln of 1, even if you place your calculator, ln of 1 is ln of 1. For you, just go on your calculator and say ln of 1. Ln of 1, you end up with 0. So here we shall have a 0. So this one vanishes to get a 0. So that means that now we are going to remain with only 1 out of 4 ln of 3. So that is how you prove it. Any questions? Is everything clear? Are we good to continue? Have we understood?
Yes.
Okay. We are going to go to the second item. Now, the second item we are going to do is here. Now, when you look at this particular item, we have a partial fraction. May I ask you to first try it out? Is it fine or we do it? What do you think? Can we first try out the item or I continue doing? Yes, Joseph? Margaret, what do you think? Should I continue doing? Okay. Now, when you look at this item, this is a partial fraction. Now, being a partial fraction, the first item they told that express it as a partial fraction. So mean that you're going to first deal with this, express it in a partial fraction. But when you look at what you are going to express, what are you noticing? You are noticing that you have two things. We have 6 minus 2x out of x plus 1. Then you have x squared plus 3. You are noticing that this one is a linear factor. Linear factor. Then this one is a quadratic factor. So you need to remember that when you have a linear factor, how do you express it? So I'll have this one equaling to or equivalent to a out of x plus 1 because this is a linear factor. But this one being a quadratic factor, then the way we express it is different. So we shall say this is bx plus c everything divided by x squared plus 3. But always you first check out before whether this quadratic factor can't be simplified further. Sometimes they can give you the same number, but they put for you x squared minus maybe minus 9. So when you check this one can be simplified further. So for such, it means that you need to first simplify it until it can't be simplified any further. So now this is what we have. Now from here, we are going to go on and build our equation. So from here, we know that we shall have 6 minus 2x will be equivalent or will be equal to a into x squared plus 3, then plus bx plus c, everything into x plus 1. Now, whenever you have a linear factor and a quadratic factor, you can first eliminate 1. How are we going to eliminate? When I look at this one here, I can easily use it to eliminate. So I'm going to say when x plus 1 equals to 0, I'll have x is equal to negative 1. So I'm going to substitute negative 1 throughout. So I'll have 6 minus 2 times negative 1 will equal to a into negative 1 squared plus 3, then plus my b times negative 1 plus c into negative 1 plus 1. Negative 1 plus 1 is 0, so the whole of this one is going to become 0. So I remain with here 6 minus 2 times negative 1, which is 6 plus 2 equaling to a. Negative 1, here better always put a bracket. Negative 1 squared is 1 plus 3, which is 4. So 6 plus 2, which gives us 8, equaling to 4a. I divide by 4, divide by 4. So my a will end up being 2. Now, after obtaining your a, you are going to go on and obtain what your b is equal to, or what you are getting for your b. Now, since you have, hope you are noticing that here under b, when you look at b here, you are noticing that b has a coefficient of x. So you can first eliminate b. How are you going to do it? You are going to say, now, when x is equal to 0. When x is equal to 0, it means wherever there is x in this first expression of yours, you put 0. So I'll have 6 minus 2 times 0 will equal to a, which we have obtained as 2 into 0 squared plus 3, then plus b times 0 plus c into 0 plus 1. So here we shall have 6 equaling to, this is 2 times 3, which is going to be 6, plus this is going to be 0, C times 1, which is equal to C. So you are noticing that your C is going to be 0. Now, after obtaining your C is equal to 0, then it means that for the you can come back to your equation and substitute. So our equation, when we substitute here, we have 6 minus 2x will be giving us our A, which we have already obtained as 2x squared plus 3, then plus C is 0, so we have bx into x plus 1. Now, for such a case, what you do, you let your x to be any value of your choice. You can say when x is equal to 1, as long as you don't let it to equal to 0, because the moment it equals to 0, everything will vanish. So when x is equal to 1, I'll have 6 minus 2 times 1 equaling to 2 into 1 squared plus 3, then plus b, which is 1, this is b times 1 into 1 plus 1. So this will give us 6 minus 2, which will give us 2 into, this is going to be 4 plus b into 2. So this 6 minus 2, that is 4, equaling to 8 plus the 2b. Then you take the 8 this side, it becomes 4 minus 8 equals to 2b. So this will give us negative 4. Negative 4 equals to 2b. So your b will be negative 2. Yeah. Okay. So after getting those ones, we are going to go back and substitute here. We are going to go back and then substitute. So from here, I'm going to go and then substitute for my A and then substitute for B. So you'll notice that we shall have 6 minus 2x, everything out of x plus 1 into x squared plus 3 is equal to our A. A will obtain it as 2 out of x plus 1, then plus the B. Remember, we had our b as negative 2x, then the c was 0. Everything was out of x squared plus 3. So I can write it now in a much better way as 2 out of x plus 1 minus 2x out of x squared plus 3. So that is our expression was a partial fraction. Members, are we on the same page? Have we understood?
Yeah.
Okay. Now, after expressing it as a partial fraction, the next thing we have to do, we have to go, they told us from the question, when you look at the question wanted us to evaluate. So, they want us to evaluate. So can I first ask you to try out everyone to integrate? Let everyone first try out. Let everyone first try out. Okay, let me hope everyone has been able to try out. Yes. Now we are going to integrate. Now the first one, when you look at it very well, you can note that the first one still, we are going to use our knowledge. So when you look at the first one, it is 2 into x plus 1 dx. Now when you look at this one, you notice that this one, we can deal with it without using the knowledge of ln or natural log. Because when you look at it here, we shall integrate and have 2 natural log of x plus 1. Because when you differentiate this, you go back to the original thing, then plus c. Then when we come to the second one here, where we have 2x out of x squared plus 3 dx. What does it mean? Now here you have 2 ways you can approach it. One, you can still use your knowledge of natural log. Because when you look at it very well, you notice that when you look at what we have in the denominator and differentiate it, you notice that you get exactly what is up. So this one still, we can have it as natural log of x squared plus 3 because plus the constant. Because when you differentiate it, when you differentiate this x squared plus 2x, you'll get 2x, everything divided by x squared plus 3. So meaning that you can as well use the knowledge of natural log. So when I come here, I'm going to just come here and say, here I'll have 2 natural log of x plus 1 minus, here we shall have the natural log of x squared plus 3, then plus the constant. Then we are going to first check whether they gave us limits. Yes, they gave us limits from 1 to 3. So I'm going to first simplify. Here our limits were from 1 to 3. So there is no need for you to put the constant. So here we shall have our limits from 1 to 3. But if you want, you can first simplify what this. So to simplify it, I can first come here and say, now I have obtained 2 natural log of x plus 1 minus the natural log of x squared plus 3. Now, you remember natural log, these are like logs, eh? So you can deal with it the way you deal with logs. If you want, so this is the same as having here x plus 1 everything squared minus the integral of x squared plus 3. So in natural log, when you are subtracting, you divide. So this is like having x plus 1 squared out of x plus 3. If you want, you can deal with it in that way. In case you feel it may disturb you, then it is okay. Deal with it the way, put the limits the way it is here. So, meaning here, when I put the way it is, I'll put 3 first. So I'll have 2 ln of 3 plus 1 minus ln of, that is 3 squared plus 3. Then minus, this is going to be 2 ln of 1 plus 1, then minus ln. Here it's going to be 1 squared plus 3. So when I simplify inside what I have in the bracket, I'll have 2 ln of 4 minus ln, that is 3 squared 9. This is going to be 12. That is for upper, minus what I have in lower. It's going to be 2 ln of 2 minus ln. This is 1 plus 3, which is a 4. So when you try to open up your thing, or when you continue simplifying, this is going to be ln. This 2 can come here and it becomes 4 squared, which gives us 16 minus ln of 12 minus this one can become ln of 4 minus ln of 4. Remember, there is a bracket here. Then from here, you can just place in your calculator and get, in case they want it to, because they told us to evaluate and write your answer to 4 decimal places. So you can just now put it in a calculator and simplify ln of 12 minus ln of 4 plus ln of 4. So you notice when you continue, this will be ln of 16 minus ln of 12 minus ln of 4, but ln of 4 minus ln of 4, that is automatically 0. So I didn't notice that clear. That is 0. So you remain with ln of 16 minus ln of 12. So if you want, you can if you want here, you can still simplify and say this is ln 16 out of 12, and then you can reduce that ln of 16 out of this, which gives you ln of 4 out of 3. But since they told us to 4 decimal places, then you go on and place what is ln of 4 out of 3 on your calculator. So ln of 4 out of 3 is given by 0.287682. Now, what you do not just approximate from the calc. Make sure that you first write at least to a given number of decimal places beyond what you have been told to estimate, and then after come and say, now to 4 decimal places, I'll estimate it as 0.2877. Since they said 4 decimal places, you'll end here. 2877. Those are the 4 decimal places. So that is how you attempt the number. And whenever they specify to the number of decimal places, then you must give it to that particular number of decimal places. Yeah. So are we on the same page? Is that clear? Any questions? Any questions? Have we understood? Okay. Okay. Okay, I think it is fine. Understood. Okay. So, I can continue. So what we are going to do now, I'm going to first give you the chance to do what? To practice. So I'm going to share those who came in a bit late. I'm going now to ask you to take screenshots of the paper we are discussing, and then you are going to take your time, do it. When you finish, you let me know, and then I can uh, let me display the paper such that members can take a screenshot, and then we shall start from that point. I want you to do it